So without further ado, welcome. My name is Logan O'Brien. I'm here with the picoCTF team, and this is our first episode, our first series on basic symmetric cryptography. And today we'll be talking about the basics of cryptography and then doing a quick walkthrough of the Vigenere challenge. So we'll go ahead and get started. So first, we'll be going over what is picoCTF, and then we're going to go over the actual lesson of the day, and then we'll go through a quick walkthrough. The whole idea behind the educational series is that it's quick, that it's educational. You kind of get in, you get out, and you can do a quick walkthrough of a picoCTF challenge on our platform, and then you can be on your way. So with that, what is picoCTF? If you're not familiar with what picoCTF is, we're an entirely free and accessible through the web education platform for cybersecurity. Now, a lot of people like to ask, what is cybersecurity? And so this is how we define it here at picoCTF. It's a variety of skills that you can learn over time, items such as web exploitation, cryptography, reverse engineering, forensics, binary exploitation, competitions, and of course, resume skills. So we'll go over to the competition next. We just had our last competition. It just ended on March 17th. But if you're interested in doing that for the following year, normally it happens around the March timeframe. But it's a lot of fun. You get to have a team put together, and you get to solve challenges for points and to try to compete versus other teams. And if you win, of course, there's a prize. And resume skills. There are a lot of employers out there where you don't need a college education. All you need is some of these skills up here that picoCTF teaches. And you're able to have a lot of marketable skills for the future. But this is what picoCTF is. If you'd like to join, here's how you can join. And so I'll leave this up here for just for a moment. But whenever you go onto our website, you should see a button either log in or create. And so go ahead and create an account. Fill out any information that it asks for. If it's optional, don't feel like you have to put anything. Please create an account, because we'll be using this here in just a moment to do our quick walkthrough. Again, that's https://picoctf.org. All right. So while you're working on that, I also want to talk about the basics of cryptography. So cryptography is the idea that I can speak to someone, and somebody that's listening to my conversation doesn't know exactly what I'm saying, and they have a hard time making out the message, if that makes sense. So cryptography has been used all over the course of history, and of course this is not a history lesson today. But it was used by Julius Caesar. Emperor Julius Caesar in Rome was the first reported use of it. However, we're going to go into the actual application of it. But as far as cryptography goes, the idea is that you can communicate without somebody, what we call on the wire, actually being able to listen to what you're saying and understand what you're saying. All right, so going into what cryptography is more on a technical level, it's turning information into a format that only intended targets can read. And this can be anything like sensitive information, maybe it's important government information, maybe it's just notes passing in class whenever you're in school. Whatever it may be, this is what we call cryptography. Now, cryptography and encryption go hand in hand. What encryption is there's really two main differences with encryption, or different types. We've got the symmetric encryption, and then we have asymmetric encryption. So symmetric encryption is really what we'll be talking about today with the Vigenere cipher. But we'll be talking about both the Caesar cipher and Vigenere cipher. And then asymmetric encryption, which we do plan on doing in a future lesson, things like RSA. If you've heard of RSA before, this is a more advanced encryption standard that we use in the modern day. But what is symmetric cryptography? If you remember one thing from this presentation, symmetric cryptography is that there is one key and it's shared. And so the whole idea of cryptography is that there is garbled text, is what we call it. Let's say it's the name hello. It's the text hello. And then when it's applied with a key using some algorithm, it's transformed into garbledness. Now, whoever's getting the garbledness, this hello message that's been turned into what we call ciphertext, can use this shared key in order to change the garbledness back into plain text, is the idea behind symmetric cryptography. There's one single shared key. So we can't talk about cryptography without talking about Caesar's cipher. So again, this was reported to used by Julius Caesar, so he could communicate with his armies. But if a messenger were to be intercepted, they would not be able to understand what the message was. It would be what we call encrypted. So this is a very basic encryption standard. It's probably the most basic there is. But the key in this instance is a shift amount. And just pretend like you have the alphabet, and we have this alphabet here from IBM. Pretend like you have the alphabet and you're shifting all the letters by a certain number. And so we have an example here, but this is called the simple substitution cipher, and it's with a shared key. So if I'm communicating with my buddy next door, I can say, hey, we're going to be shifting the alphabet by 4 characters, and we have to exchange that information first, but 4 characters. And the Caesar cipher is used to show this. So let's say we have plain text is what we call it. So this is the message that I want to share. The plain text is picoCTF. That's it. And we have a key/shift amount of 4. And so every letter is going to be shifted by 4 to the right down the alphabet. And if it gets to the end of the alphabet, it actually loops back around. So if you're on Z and you do shift by 4, you kind of loop back around, right? As you can see by the picture here, A maps to X, B maps to Y in this particular example from IBM. But with picoCTF, shift by 4, P becomes T, I becomes M, C becomes G, and O becomes S. And so if somebody was listening to my conversation and I'm using Caesar cipher, they would just see TMGS. And they say, I don't know what that means. Is it an acronym? Is it like a text slang word? Like, what's going on here? This is the idea behind basic cryptography and Caesar cipher. But what are we actually talking about today? This is the Vigenere cipher. And yes, I have important there, CTF info, but this is a polyalphabetic cipher that uses a repeating keyword. Okay, so and we're going to have an example, but let's pretend we have a very long string that is, we'll call it 30 characters. And we have a key that might be 5 characters. That key is going to be used for each corresponding letter in the string. Again, we're going to show an example here in just a moment. But it uses a repeating keyword, and this is similar to the Caesar cipher, except it's not a shift by an amount, it's a shift by another letter. And we do have a chart here. So this is a chart. This image is from ResearchGate. But the idea is at the top row here, and you should be able to see my mouse, at the top row here, we have the plain text. So this is whatever you are wanting to encrypt. This is your message. And the key over here is whatever key that you want to use. And so we do have an example just to walk us through this. The example is the plain text is picoCTF rocks, right? picoCTF rocks. Again, this is the message that we want to keep secret from other people, but this is what we know to encrypt everything. Our key is just the 5-letter word learn. Just the key learn. And the ciphertext actually comes out to this garbled mess here, but I do want to kind of go over how we do that. So you can see my mouse here moving around. picoCTF, we'll start with just the letter P, okay? And this is the key here, learn, LE. And so because the plain text is 12 characters long, and we have the key, which is 5 characters long, we have to repeat the key as long as it takes to complete the rest of the plain text. And so again, P maps with L, I maps with E, and so on. You can kind of continue down the road here. But we'll start with P. So P is the plain text. So we'll go over here and we'll find P. And L is our key. And so we'll go over to the key and find L. And whenever we map up L, we're going to kind of drag our mouse here, and L all the way to P, we land on A. And so if we go up, we can see that it maps to A. So all the text in here is going to be what we call our ciphertext. And by matching these things up, you create a ciphertext, which is this AMC, FPE, JR, etc. Right? This is what it maps to. And so, and again, if at any point anybody has any questions, feel free to drop them in the chat. We'd love to answer them. We have a few fellow picoCTF members here with us that are happy to answer them. But this is the idea with a Vigenere cipher. You take the plain text and you take the ciphertext, and you take the key and you produce the ciphertext. Now, I'm going to ask this question. I know it'll be rhetorical because unless you want to drop in the chat for me, that'd be great. But we do have the ciphertext. Now, if we're given the ciphertext and we're given the key, how can we find the plain text? So we're given the ciphertext, so we have items inside, and we're given the key. How do we find the plain text? So while you're thinking through it, the whole idea behind ciphertext is that we can find a letter in here. So let's say that the letter is A, right? Just for the sake of this example, pretend like picoCTF is not here. We have the letter A for the ciphertext. So we know we're looking for A, and we know the first letter of the key is L. And because it's a one-to-one mapping, right, we're going to look for the key L. So go down here, we find L, and then we're going to look for A. And so we're kind of just going to go across. We'll drag our mouse all the way across and look for A. And eventually, we find A. And so if we didn't know the plain text, I know it's here on the screen, but if we didn't know here the plain text, we just drag it up, and guess what? There's the P for picoCTF rocks. And so eventually, you work your way through, and you're able to unencrypt the ciphertext, given just the ciphertext and the key. Okay, so we do have a walkthrough of Vigenere. I'm going to give everyone just a few minutes to set up your picoCTF platform. And so I'll be back in about, we'll do about 30 seconds to a minute. Okay, I'll be right back. All right, so hopefully at this point you were able to set up your picoCTF accounts. If not, try to catch up for us, or you can watch back this video later, but we do have a picoCTF account up here. So this is what you're gonna see if after you create your account, this is your first time, you're able to click on practice. And in practice, you can see all of the challenges that we have going on. We have a variety of ways to look for different challenges. And so I'll give a quick rundown of the platform, as this is our first web series. But we got difficulty. You can go easy, medium, hard difficulties of all the categories that we talked about at the beginning of the presentation. And you can see all the events that we've had. So this is our picoCTF 2025. These were all the challenges that were in that past competition. And it's quite easy to filter this way. You can hide the ones that you've solved, et cetera, et cetera. As far as progress tracker goes, you can see how many challenges that you've solved over time. And you can, of course, filter by different categories too. So we will start, though, and we're going to search over here to the Vigenere cipher. And we'll pull this up. So this is medium. As far as difficulty level goes, it's under the cryptography category, and this was from the picoCTF 2022 challenge. So it's going to say, can you decrypt this message? And the message is going to be here in this file. And it's going to say using this key scilab, right? Scilab. So we had the example from last time, and before we get rolling with this challenge, we know that we're decrypting something in a text file once we download that, and they're giving us a key. So this is the same example that we went through last time, right? We're going to have both the key and we're going to have what we call the ciphertext. And so let's go ahead and download the message. So up here, you'll see cipher.txt. And so go ahead and download that. When you open it up, you're going to see something like this. You're going to see RGNO, DVD, or something similar for your ciphertext. And, of course, we have the key, which is Scilab. Scilab is an organization, an institution at Carnegie Mellon University. And so that, as we're from Carnegie Mellon, we have that as our key here. So we have this, what looks to be a flag. If you've played picoCTF before, this is a very common way to see a flag, right? So you're going to have something, maybe picoCTF here. You're going to see some brackets. You're going to see some stuff in the middle. That is in general what a flag is. So I'm going to pull out my pen here. And we have R and we have C. And so this is the manual way to do it. I'm going to show an easier way to do it just in a moment on like an online solver, but the whole idea behind the web series is that we teach cyber educational skills, and this is just the basics of cryptography. So we have R and we have C. Now R is not the plain text, right? R is going to be the ciphertext. And so we know the key is C, and we know the ciphertext is R. So we'll go over here to C. I'm going to circle C here. And we're going to drag over until we see R. So we see R right there. And so we see P is our plain text. And as we could have probably predicted, just knowing picoCTF flags, the first letter is going to be a P, right? And so we can work through all the way down here. We'll do a few more characters just to get the point across, and then we'll show an online solver that'll get you the flag. But so P is first, and then you can see Y and you can see G. So let's go over to Y. Again, that's going to be our key, and then our ciphertext is going to be the G. So we'll go all the way over to find the G. And then you go all the way up, and guess what? You see the I, right? So that's PI. And we're slowly going to be decoding this. So we'll do two more, and then we'll switch over. So we got N, and N maps with L. So N is going to be our ciphertext. It's going to be the stuff in here. And then L maps with our key. So L is going to be here, and N is going to be here. And so we go up, find the C value, and that's P for picoC, PIC. And one more, if you haven't found the pattern here already. Here's the O value, and this maps with the A value here. So A is going to be our key. O is going to be our ciphertext. And actually, this time O maps with O. So we have pico. And as you continue down this, you're going to find eventually that you can obtain a flag. And so I'll produce the flag here, what it actually comes up with. Let me turn off my pen here. And you'll see the actual the flag over time. You slowly decode it, and you can see the end result. I'll move my face over here. There we go. So you can see the whole flag there. Now there are online encoders and decoders that will do this for you, and I'll go ahead and show you guys one here. I have one pulled up. This is just it's just one of the random websites I found by a quick Google search looking for looking for Vigenere cipher encoders and decoders. And the whole idea here is that you paste either the plain text or the ciphertext here, and you can change these to be a variety of different types of data. And you can encode or decode, and it will change ciphertext and plain text for you. And you'll enter the ciphertext here, you'll enter the key, you'll enter the plain text, and then you'll enter the ciphertext, enter the key, and the plain text will be produced by the algorithm in the background. And so the whole idea here is that it's not using any magic, right? It's just using the whole idea that we talked about here with this is a simple chart that aligns characters with keys, plain text, and the ciphertext in the middle. So here are the walkthrough steps if you're wanting to replicate this at any time. You're able to go online to playpicoCTF.org, sign up for an account. Under practice, search for Vigenere, click on the challenge. You'll download that text file, decrypt the message either by hand or using an online decoder, and then you can submit the flag. And so this is our walkthrough for Vigenere cipher. So in general, this is what we talked about today. We talked about what picoCTF is and who we are as an organization. Again, we're completely free, and we're here to educate as much as we can through our online picoCTF platform with cybersecurity. How we define cybersecurity was over on a few slides, and it's those categories that are in our platform. You can look at those. And this is what we talked about. We talked about basic symmetric cryptography. We talked about what is cryptography. Again, it's the idea that you can communicate a message and somebody that's in the middle can't understand what's going on unless they have that shared key. We talked about symmetric crypto, Caesar cipher, and Vigenere cipher. And we will be talking about asymmetric cryptography next time. So as a little bit of a preview to that. As far as symmetric crypto, this is one single shared key. Asymmetric crypto is where you have different keys, but you have something called a public key and a private key, and you're able to work with those in order to encrypt and decrypt messages. And of course, we did our walkthrough for picoCTF. Join me next time. We're going to be doing this probably once a week, once every other week to... I'm going to move my face here. There we go. We're going to be doing this once a week, once every other week, depending on the feedback that we get. But any feedback that you have, we would love to hear from you. And so thanks for being here with us. And yes, shout out to the chat. Online solver is much easier. But thanks everybody for being here. We'll see you next time.